Okay, a very good morning to all. Our resource persons, Professor I.K. Rana and Dr. Surendranath Reddy, Mr. Brian D'Souza are in charge of MSc Mathematics, Government College Sankalin, and all the teachers and students who have joined today for this workshop. Hello, I am Rohit Redkar, Assistant Professor in Mathematics at Government College Sankalin, Goa. I welcome you all to this workshop on Geogebra titled Bringing Math to Life with Geogebra Applets. Okay, so this workshop is in fact a part of the bigger event, Axiom, which is a national level intercollegiate event in mathematics, which we'll be having in our college on 3rd and 4th of March. This workshop is organized by the Postgraduate Department of Mathematics, Government College Sankalin, financially assisted by the Directorate of Higher Education, Government of Goa, and Department of Science, Technology and Waste Management, Government of Goa. Our primary aim of conducting this workshop was to give the participants in Axiom a basic idea about what GeoGebra applets are and how to create them so that it helps them for the GeoGebra applet making competition to be held during the Axiom. But rather than restricting to only the participants of Axiom, we have kept it open for all those who are interested in learning the basics of GeoGebra, as this workshop will be beneficial to make their students understand certain mathematical concepts in a visual manner with the help of these applets, and also for the students to learn the same. So from the two sessions which we'll be having, one of which will be starting in some time and the other which is scheduled for tomorrow, I hope everyone takes as much as they can and then learn further things possibly on their own to create better applets to make the teaching learning process in mathematics interesting. With this, I once again welcome you all to this workshop. So since a principal won't be available for this because he has gone for some official work, he won't be able to address the participants. So I request Mr. Brian D'Souza, Assistant Professor in Mathematics and in charge of MSc Mathematics, to say a few words.
Thanks, Rohit. Um, Good morning to all, to our eminent resource persons, Professor Inder Rana and Dr. Surendranath Reddy, um, the coordinator of the program, Rohit Redkar, other faculty members from the Department of Mathematics, uh, teachers, students, and my dear participants. A warm welcome to you all, especially uh, to our resource persons and to all the participants who have joined from all over the country. Uh, I had the privilege of attending Professor Rana's lectures during the International GeoGebra Conference in March 2021. It was then that we got exposure to GeoGebra applet making, and Dr. Surendranath Reddy also showed us how to. I think it was um, what is that? There was this a virtual visualization
Augmented
that
reality, augmented
yeah,
reality.
augmented reality, exactly, which Professor Dr. Surendranath Reddy had taken. So it was then that we got this idea that we could have a competition where we would incentivize students that through the competitive incentive to learn acquire these skills. So in an intercollege competition, students tend to be quite uh, charged up to win the competition. So they will take enthusiasm in an enthusiastic manner. They will go and try to learn as much as they can. So we thought for a competition we would help spread this word of GeoGebra around. And so for Axiom 2023, we are going to have this competition, Planet of the Apps, in which the students will have to make GeoGebra applets and present it. Now, Axiom 2020 was held in, Rohit has already spoken about Axiom, but the first Axiom was held in 2020, in January 2020. And we had enthusiastic participants, around 200 participants from around 11 colleges participated. And unfortunately, because of the pandemic, we couldn't have it for the last couple of years. But this year, Axiom Battle of the Minds will be hosted at Government College Sankilin. It's an event of mathematical intelligence and logical reasoning, and we are happy to say that 12 teams have already registered for the competition, 10 from within Goa and one from New Delhi and Kerala. We are looking forward to welcome you all to our college campus on the 3rd and 4th of March, and many of those participants are here to acquire the skills for the GeoGebra applet making competition, as well as there are many others from college teachers as well as students who have come to immerse themselves in GeoGebra. So at Axiom, we are going to have quizzes from the history of math to general knowledge quiz to debate competitions to scientific model making. So we look forward to welcoming you here. Now, related to this, that the competitions that are, designed are basically related to mathematics and the allied sciences around it. So once again, I welcome you all and I welcome the resource persons and we look forward to hearing from you over the from the next couple of days. So with those words, I welcome you and thank you. And over to you, Rohit.
Thank you, sir, for your insightful words. Now I request Mr. Amit Thakur, Assistant Professor in Mathematics, to introduce the resource persons. Over to you, Amit.
Hello everyone. Am I audible?
Yes, Amit.
Okay, thank you. Good morning to all. I'm Amit Thakur, Assistant Professor in Mathematics at Government College of Arts, Science and Commerce, Sunny Goa. It's my pleasure to introduce our guest speakers for the two-day webinar on GeoGebra applet making. Today, we have with us Dr. Inder K. Rana, sir, ex-professor in mathematics at IIT Bombay. Sir has a 36 years of experience from teaching from BTech to MSc students at IIT Bombay. Sir completed his MSc at Mumbai University and PhD at Indian Statistical Institute, Kolkata. From 2015 to 2020, Sir was an emeritus fellow at IIT Bombay. And after retirement as a full professor, Sir started working as a visiting faculty at various institutions. Sir was an adjunct professor at IIT Jodhpur. In 2009, Sir was a visiting faculty at Ohio University of USA. Sir had a 16 research publications in international journals and presented several papers at various conferences. Sir has publication. Sir has published books such as Introduction to Measure and Integration, From Geometry to Algebra, and books like From Number to Analysis, published by World Scientific Press. Sir has developed a web-based course on calculus and linear algebra, which is very popular. Sir has been awarded several awards for his excellence in teaching, like C.L. Channa Mathematics Award, Aryabhatta Award, Excellence in Teaching Award, and Lifetime Achievement Award, and many more. Sir regularly organizes training programs for students as well as teachers. Sir is a founder of National Conference Time, that is Technology and Innovation in Mathematics Education, which has been held once a 2 years. And recently, from 2021, Sir is organizing an International GeoGebra Conference India. This is not the only way to introduce Sir. Sir has an extensive and a wonderful biodata. We are happy to have you, sir, here. And thank you so much for taking a time from a busy schedule and being there with us. Thank you, sir. Also,
I think okay.
thank you.
I think
I hand over,
Amit.
sir.
I, okay, Rohit, we can take over. I think in the last part we lost.
Okay, so because the some network issues, we couldn't hear Amit. But okay, last now we hand over it to you, sir. Professor Inder Kirana, you can take over. You can start with your
Okay.
session.
Thank you, Amit, for the introduction, and Rohit and Brian to rope me in for this workshop. Thank you very much for the invitation, and I'm happy to spread or give back whatever I can for GeoGebra today. And Surendra Reddy is there to give add-ons tomorrow morning, tomorrow afternoon probably, I think. Yeah. Okay. So let me begin by when Brian said that there are participants from the college teams and outside. I just want to sort of get to know all of you. So can I share my screen now?
Yes, yes, sir. You can share your screen.
Okay. So let me share my screen. Uh, okay.
Yes, it is visible. Uh,
It's visible.
but we are
Okay.
but we
Good.
are getting your Google Meet.
Yeah. Yeah.
We can
Okay.
see.
Uh, let me see what I want to show. I'm showing my entire screen, but why is it not showing? Is the some web page visible or not? Okay. Yeah. So let us.
It is visible. It is
Yeah.
visible.
Okay. Good. If all the participants have access to internet and they have a laptop or a mobile, they can try to enter this website. Probably let me copy it, copy link, and put it in the chat box so that everybody can. Where is the chat box gone? I can't see the chat box in Meet. Okay, here. So let me put, and please click and see whether you can see something or. So click on this link which I have put in the chat box, and please enter whatever is asked for. Yes, so I can see at least one person has responded. I just want to, there is no privacy issue involved. I just want to know how many are participants of what level, and so that I can accordingly uh, do my. Well, do it fast, please, because otherwise we'll be losing time. It's just a short introduction to knowing. So there are about 10 students, 5 teachers at present. I can see them. Oh, I can see the number, not the persons. So I think majority are students, and so fine. I think there is nobody from the third category. I thought some educator may be interested in knowing about GeoGebra. But anyway, so let us thank you for submitting. I just wanted to introduce this idea of getting a quiz kind of thing incorporated in your online classes. So this is a very easy way of doing it and getting some information. Thank you those who have participated. So let me go over to. I just want to see the level of GeoGebra that you are using or you know about, so that so let me put this also in the link copied. And where do I put it? I put it in the chat box. The second link I'm putting, which tells how much of GeoGebra knowledge you have, so that from where do I start. So please go back to respond back. What is your knowledge level of GeoGebra? Four, five, and six. Five, five, six. Equalize. Wow. So 24 people have, you can see 25 people have participated, and 26. So majority of the people seems to be either unaware of GeoGebra or know a little about it. And so there are quite those who have participated, about 9 have said they know it moderately well, and there is one person who knows very well. And is that Surendra, you?
Participate because I thought
Yeah, okay, good. I was hoping that you will enter somewhere, and
okay.
good. Okay, so this is I'm just this is a short way of knowing the participants, their level, and so on, and also putting up mathematical quizzes. So do try to use this what is called uh, quiz formation and online evaluation. So let me, I think, begin with my presentation preamble. So let us start with the. Is this visible to everybody now?
Yes,
My
sir.
screen? Yeah.
Yes, sir.
So feel free to, whenever you feel like saying something, unmute yourself and let me know how we can sort of respond back. So I don't mind you asking questions. Okay. So please feel free to ask questions whenever you feel like. I can't see my chat box along with it in the full screen. Can I see the chat box? Yeah, I think it's available. Is this much of screen okay for everybody? Surendra, can you say that this
Yes,
much
sir. That is
screen,
Yes, sir.
that is good enough?
Yes.
yes, sir. Okay.
So I will be asking you something about questions, so you can enter in the chat box. So I have drawn some picture on which is visible to you. So this is the picture. I would like somebody to explain what is drawn here on the picture. So somebody from the participants can unmute and say, I don't mind who wants to unmute. I don't have any objections. Uh, somebody, or shall I pick up somebody just to see? So in the participants, okay. Avasthi Panikar, are you there? Avasthi Panikar, no response. Ashutosh, who is there? Ashutosh, no. I'm trying to make it interactive. A workshop should be an interactive session where you ask questions, answer
Or
questions.
two-line segment.
Okay, Avasthi Panikar says there are two line segments. Can you say what are the two line segments?
AB and CD.
AB
CJ
and
is
C.
also there.
Yeah, these are two line segments. What else is there?
CD. Circle.
There are two circles,
Yeah.
right? One is dashed boundary and other is segment also has a boundary. Segment also has a dashed line segment. And there is point J. Where is the point J? Can you say something?
It is the bit. It is between C and D.
It is between C and D. Very good. And do you think it lies on the line segment CD? Yes, Avasthi. Yes or no? At least the picture shows that the point J lies on the segment CD, right? Do you agree?
It's a dotted line.
Yeah, dashed line. There seems to be a point on the dashed line. So this is a picture which which probably a teacher will draw it on the board, or which you would draw it on a paper and pencil. So what do you think this picture? Do you think this picture is a? Can I change this picture? If I want to change, what I have to do?
Changing the sense, sir.
Changing the.
Changing in sense.
I want to say I want to make the circle bigger. Okay, or I want to reposition. Instead of drawing it here, I want to draw it here somewhere.
Sir, your screen is not visible.
Yeah, it's suddenly.
It's not visible.
Your picture is visible. Maybe that window is minimized.
No, I was sharing the whole of screen. Okay. Let me see where I am.
No, sir. Your in by means your can.
Ping
Okay.
it, no? Ping it. Ping the screen, you will get.
How do you? No, no. I didn't want to screen because okay. Let me just see what is happened in this. Your screen is visible to others, right? Is it visible now?
Yes, yes. Now it is visible, sir.
Okay, fine. I don't know how it went off. Anyway, so I will try to not to move too much. So if I want to reposition this circle somewhere here, okay, and this line segment I want to bring it down here, then what I have to do? Yes, can somebody answer? So imagine this is drawn on a blackboard or drawn on a notebook. So what will I have to do? The natural thing is, yes,
Yeah, you have to rub the circle and then above the line segment,
precisely.
you have to redraw.
Precisely. So I want to change the position of one of the objects, a circle or a segment or something. I want to draw it somewhere else. Then I have to rub it off and draw it again. So that is why I call it as a static picture. Right? Once drawn, you can't change it. Okay. So the question is, can we have dynamic pictures? Can we have a picture which is dynamic? Okay. So this is the basic idea of what we are going to talk about, from static to dynamic. Okay. So let me probably show you before introducing anything else. How do I do it? So this picture, I'm going to, now it is not a blackboard, it is a whiteboard which is a part of a software called Geogebra. So the same lines, okay? You see, is it visible to everybody?
Yes, sir.
Okay, so I want to change this segment. So what I do is I just move it. Okay, I can put it somewhere here if I want to do it. If I want to change the length, I can change the length of this. Accordingly, something else is changing. But that is because these two are related. There is a point J, you see where it moves. It moves only on the, I can put it anywhere on the line. Okay, this is circle with this center. You can
Sorry to
see
disturb.
if I move it, something
Still,
is
many people can't able to see screen, including me. I am also not able to see.
How is that happening?
You staring and share again?
Okay, fine. I am sharing the full screen actually. So let
But
me do it again.
yes.
Stop sharing. I start sharing. I'm sharing my entire screen. Okay. So whatever is on the screen should be visible, right? Surendra,
Yes,
you're more expert in.
Yes.
Probably, I have
That's
not used this. Share.
Yes, share screen.
So share. So everything is visible now.
Yeah, it's uploading, sir.
Yes.
So is that
Yeah.
visible now,
Yes,
GeoGebra?
yes, visible. It's visible now. Yes.
Okay, fine. So let us hope it stays visible when I move
Yeah.
to my. What about this is visible?
Yes.
If I now GeoGebra is visible.
Yes.
Yes,
Okay.
sir.
Yes, sir.
Okay. So this is what I call dynamic picture where things can be changed. So we'll come to slowly to this. So let me close this for the time being and come over to. Okay. So this is going to be the presentation GeoGebra, a basic introduction. Um, you want to see that this this is the title of my talk is a PDF page. You can see this is a PDF. This is a page of PDF I've shown. I can show you in GeoGebra the same thing. So here is in GeoGebra. You don't see it, right?
Yeah.
Yeah. So let me show you the. So there is no magic in it. It's very simple thing. So we'll come to it probably once we have learned a bit of GeoGebra. So let me just quickly say what is GeoGebra. Okay. GeoGebra is a dynamic geometry software which was developed by a PhD student in Austria, and once he got he was a computer science student, and he developed this Java based software, and he got his PhD. And once he introduced it to the public, it became a craze. Everybody wanted to know what is GeoGebra, and not surprisingly, because it is used in geometry, in algebra, statistics, calculus, graphing, spreadsheets, and so on. It is useful in many areas of mathematics, and it can be used inside or outside the classroom for illustrations. We'll come to what are illustrations, we'll come to what are called explorations, we will come to modeling, and so on. So these are applications of GeoGebra. Okay. So let us now here is another interesting thing. Uh, Once again, let me pick up somebody and ask, what do you see? Sorry, when I click there, it goes off. Okay. Somebody by the name Siana Fernandez, is he or she there? I don't know whether name indicates anything. Yes, are you there? No.
May I,
Darshana,
sir?
yes?
May I, sir?
Yes, who is it?
Yeah, it's Kala Nayak.
Okay, fine.
Uh,
What do
there
you
is,
see on the screen?
yeah, there is a windmill.
There is a windmill, good.
There is a flag,
There is a flag,
and there is what we call, I don't know the name, where we go to,
balloon.
yeah, balloon, and
Yeah, it's a
clouds,
hot air balloon which goes
hot
up.
air balloons, and then
Yes,
clouds
and
with
there
a
are
clock.
clouds. And what do you think this is?
I thought it is a clock, sir.
Moon or sun.
Yeah, but I don't know. Some lines are there.
A yellow. Moon is hardly ever yellow. It's light
Yeah,
yellow. It's sun probably.
Sun.
Okay, doesn't matter.
it's within.
Moon or sun, whatever you want to call it.
Yeah.
Now, all this picture is a static picture, right?
Hmm.
Nothing is moving.
No.
Let us make it move.
Nice.
So there was a lot of linear algebra, your topic that you must be studying. Uh, there was a rotation of the windmill. The balloon was expanding and shrinking, and there was this flag turning this side to this side.
Okay.
The moon was moving again in a rotation, and the clouds were moving horizontally. They were going what we call as in a translation. All this was made in GeoGebra. So here is the GeoGebra applet for that. So here is the windmill. Okay.
Mm.
Now let us move the windmill alone. So I can move the windmill. You see the windmill moving. I can make the clouds move. The clouds are moving. I can balloon. Here is the balloon, hot air balloon. You see it is changing. It's becoming bigger and smaller, bigger and smaller. So I can do that. And this is the flag which changes its side. Okay. Depending on the wind condition, it goes left or right. All this is made in GeoGebra. Okay. So GeoGebra, we are going to learn. So today's part of it. Here are some tools which help us to make it, and these are called sliders, which help us to move some objects which are dependent. So probably you will, by the end of 2 days workshop, you'll be able to make an applet like this.
Sir, one question, sir.
Yes,
One doubt.
please,
One
please.
doubt. Sir,
Yeah.
those poles can't we move?
These poles,
Yeah.
you can move depending on what you have. You see, when you make a movie, you have something in mind. This is what you want to do, right? I didn't want to move the windmill. I want the pillar to be stable, right? But if you want, you can move the pillar. There is no problem. Okay, you can move the pillar. You can do many more things and so on. It's like making a film. You have to write your story first, what you want to do. Okay, then you have to write a script. This is how you want to do. This is what this person will come and do this kind of a thing. You'll use this tool and do this and so on, and then come to GeoGebra and do it. Okay, so slowly we'll do it. You can do it surely. Okay, so let us go over and so let me quickly introduce you GeoGebra. You can go to this site. You enter the word in Google GeoGebra, and you can and find out Google. And so let me probably okay. I think you can download GeoGebra. If you have not already done it, probably you should do it today or do it later on. Probably I should stop my video now. Anyway, this is not required, right? Where is my video? I can stop my video. Yeah, okay. So this is where you can download GeoGebra. Once you click that, you will enter here. The website will show you these possible ways of downloading. The best is download GeoGebra Classic 5. Okay, this is the most intuitive. There is GeoGebra 6. Don't think the latest version is the best one. For learners, GeoGebra Classic is the best one. Download it and install it. Okay, when you download it, save the file somewhere. Okay, once you have saved it, you click and install. GeoGebra will be installed with a symbol like this. Okay, and when you click that, something like this will open. Okay, a window will open. So I think let me probably see my desktop. If I can, how do I come to my desktop? Okay, I don't know. You'll see a symbol like this. So click that and GeoGebra will open. Like this. So I think, let me, once you have installed and opened GeoGebra, this is what you will get. Okay. So this has got two parts. This is called the algebra part on the left, which is blank. And this is, hello? Anybody want to ask? Somebody, mic is on. Okay. Hello? Somebody's mic is on. Please switch off your mic. Okay. Ajeshwar. Your mic is on. Please switch off. Ajeshwar Gowda, your mic is on. Please switch off. Thank you. Okay. So I'll just quickly show you something. For example, these are the tools. Here is something called point tool. What you can do with points, we have various things you can do with points. Okay. You want to, supposing I select a point. Now, where you want to draw a point, like a blackboard, you want to create a point. So I click here and you get a point A. Okay, it is named as A, and this is the point. And on the left, it says what are the coordinates of this point: 2.86, 3.08. Now, this on a blackboard is a stationary thing. You can't do anything, but here you can do many more things. So go to what is called the move. This is on the left, there is a move tool. So click on that move. Now select move and you can move this point now anywhere you like. As you change, the coordinates also change. So you know what are the new coordinates. If I bring it here, it is at 0, 0. Okay. I can put it here, it is 1, 1, and so on. So it can be very well used for coordinate geometry for creating points. Okay. And other things. So this is creating a point. Now let us, there are various things. We'll come to this slowly. So let us create a segment. So segment, what is a segment? Segment is a part of a line between 2 points. So here is a point, let us call B. So once I click segment and I clicked at B, it will not leave me till I tell what is the end point of the segment. So here is the end point C. So what I have done, I have segment, I have clicked at a point B, held it, and it goes to the point C. So this is a segment I have created. It has labeled it as F. F is a segment. It has given me the length also. So it measures algebra. It measures things and give you the algebraic inputs of that also. Now, like you saw in the static picture, on this line segment, I want to create a point. So let us create a point. Go to the point tool. So this is the point tool. Okay. Where I point on an object. So this line segment is called an object in GeoGebra. Everything, point is an object. This line is an object. Endpoints are objects. Okay. So point on an object. My object is going to be line. I want to create a point on the object. So this is an object where I want to create anywhere you like. So let us say you want to create a point and it has named the point D. It is on this line. I want to check. So I want to move this D. So how do I move? This is called the drag test. So I drag. You see the D is staying between A and B. It can't go up and can't go down. It will stay on this line because it is a point on that object. And it gives me the coordinates of point on the object. Okay. Let us create that other part of the thing, the circle. So here is the circle tool. Very intuitively, very obvious. Points, lines, and here is polygon, and here is a circle. So when I click at circle, it gives you various possibilities. You can have a circle. For a circle, you need either 2 points, one on the circumference and other on the center, or circle with a given radius. You can draw it using as you do in a compass and various other things you can do. So let us create a circle with 2 points. Okay, one as the center, other as the so let me use this point A as the center. Once I click the center, okay, and I have you see, I click and I release. Now circle is being created with A as the center. I can stop anywhere I like. I can stop. So this is a circle with A as center and E as a point on the circumference. Okay. Once again, it is dynamic. I want to move. To move anything, you have to come back to this arrow. That is a neutral gear. You come back to arrow and move. I want to move the A, okay. I move the center because I'm moving the center only. I'm not moving the point E. So the radius is also changing. So it is becoming bigger or smaller. If I like, I can move this line segment anywhere and point D will remain on it. So it remains on it. So line and segment. Anybody has questions till now? Anybody has any doubts, questions till now? Otherwise, I will go ahead. Okay, so I'm just revising. So this is the blank thing, GeoGebra. When you open it, it is the algebra window. This is what is called the graphics window. It is written here graphics and algebra. Whatever you create on the graph algebra on whatever you create on geometric panel, it is shown in the algebra. There is other way around also possible. We'll slowly come to it. Okay, so there is a bottom is input bar, okay, where you can do some kind of input. For example, this is called the input bar. Here, for example, I can create algebraically a point. So for a point, I should tell the coordinates. So a bracket, I want 2 comma 3. Okay, I want a point with 2 comma 3 coordinates. I click that and I enter, so I get a point P F, which has got coordinates 2 3. So this is algebra. You add algebra here, it is shown in the algebra window, and the geometric effect is shown here.
Sir, one doubt, sir.
Yes.
Sir, the name of the points, and they are in order, like A, B, C, D, like that.
Yeah, that is by
Can we
default.
change? Yeah, by
Yes.
default.
Okay, so let us go to that also. For example, F is a point. Okay, now on F, I click right click. Right click, what do I see? I see this is a point with coordinates to F. I can show its polar coordinates if I want. Show object. If I click that, now it is gone. Okay. If I want to show it again, I have to go to the algebra window. You see here, this algebra window F was big white. So I click it again, the point comes back. So show and hide a object is done by clicking this or clicking back. Show the label, right? Okay, let us click show the label. It is showing the label, gone, label is gone. Let me do it again. Show the label. So label F comes back. Okay. So what else is possible? You can put a trace on. What is trace? That means if I move this point, right, it will trace the path along which I am moving. So let us do the trace on. Trace on, and let me move this point now F. Now you see when I'm moving F, it is telling me the path along which I have moved. Okay. So this is the trace on. Now I can, now here is the question you ask, can I rename it? Yes.
Yes, sir.
So here is the property you can rename. Instead of what name would you like to give it? Your preference,
Yeah.
you tell me.
Yes,
Huh?
sir. K.
K. Okay. So I type K here. Okay. Okay. So now it has become, where is the point? It has become K, not very much visible. So let me bring it out. Okay. Here is K. I think, okay. Now if things are not very much visible because the font size is small, I can change. So go to options at the top. There is options here. Okay. Font size. By default, it is 12. I can make font size whatever I like. So let me make it 20. So when I make it 20, things become bigger and you are able to see it, visualize it, see it better. So this is the point K. Okay. It had
Thank you,
trace
sir.
on. Let me remove the trace. Okay. Let us see what else is possible. All this, I can delete the object if I want. Okay. Let us keep it for the aiming. Okay. All these properties are combined together in what is called object properties. When I select that, it tells me all the object properties of that object K, which is a point. So basic name is K. If you want, you can give it a caption. You can call it some name, say K is the default label which is given, okay, and you want to give it some other name. So let us get the independent point. Independent point. I have called it as independent point. This is a caption, right? Now, here is a show label. At present, it is showing the name, which is K. I can change it. I can show the caption. Now you see it has changed, independent point. So you can give a independent name that will be called as a caption, and that thing will appear as with that caption. Okay, I can change the color of this point. So here are at present it is blue. If you want to change, I can give it a red color. Okay, I can give it a pink color. I can give it a yellow color, or whatever you like. You can give a this color. So this is a color choice. Style. Style is how big you want this point to be, right? If I make it, it makes it smaller, it makes it bigger, smaller and bigger. Okay. Point size, and then point style. You can change the style of it, whether you want a dot, or you want a cross, or you want a plus sign, or you want this kind of thing. So many choices are possible. You can put this, or you can put whatever you like. Okay, so you can put any kind of. So all these are possible. Basic, color and style. Here is the algebra. Okay, I am not going into algebra. It's the Cartesian coordinates. Okay, you can change when you move, how much it should change, and so on. So these are some more properties. We'll come to it a bit later. So renaming and the object properties. Everybody has gotten that much?
Yes, sir. Thank you.
Anybody has any doubt or thinking, how do I do this thing in GeoGebra? Till now, whatever we have done. Okay, now supposing you have created this applet, okay, and you want, there are many things you can do. You can go to this file, you can save it, save as. When you say save as, it will ask you with what name you want to save and where you want to save, right? Like Microsoft Word file, you can give a name and save. So let me not save it for the time being. Okay. What else you can do? What you can also do is you have drawn this picture, okay, and you want to use this picture somewhere in your document, some document. So there is a possibility of export. You can export this geometric part, okay, as a graphic. It will save as PNG or EPS format. You can make it as a GIF. These are advanced things. Will not go into at present into this. That slowly you should try to figure out. Let us say you want to save it as a picture, PNG, right? So it will save this as a picture. This is a resolution. You can increase the resolution. This is the size of the picture, okay? And you are saving it as a PNG file, okay? PNG, you can include it in a Microsoft Word. You can save it as a PDF, EPS, and so on, okay? So save, once you say save, it will ask you where you want to save it as usual, as a PNG file and so on. So let me not save it, let me cancel it. So this is how to save. Once you save it, it will save it as a GeoGebra file. Your file will be saved as whatever name you give, .ggb. For example, let me show you something. For example, all these things I have saved, okay, and all these files are saved with a file type as ggb. So gg means ggb, GeoGebra file, okay. So this is saved as a GeoGebra format, and once you click, it will open in GeoGebra back. So this is there with you lifelong, as long as you don't delete it. Okay, so you can save it as a GeoGebra file, you can save it as, export it as a picture. Many things are possible. Okay, so once you have done it and saved it, I want to create a new one. So let us go to a new, I want to start a new, making a new applet. So let us make it new. Okay, it will ask me again whether you want to save this or not. Have you saved it or not? Whether you want to save it or not. Okay, I don't want to save it, so I cancel it. Okay, so where is new? So I come to new. I say don't save it. So I get a new panel. So you can create an applet, save it, you can export the picture. Anything else you want to ask for the time being? Okay, so let us start creating something mathematical. I want to create a square. Okay, so Ashima Golatkar, are you there? Ashima, are you there? Okay, let me ask somebody else. Jagannath Parab, are you there? Jagannath Parab, are you there? No?
Yes, sir.
Yes, Jagannath. Can you tell me what is a square? It is an object.
All four sides are equal.
Of what? I'm asking a question comes in the exam. What is a square? So what will you answer? You will write. Yes. Tell me what is a square?
All four sides are equal of any shape.
Of the shape. Okay. Where are the sides of a circle? One at a time. Okay. I think that is a better I call Deepika Gowns. Are you there? Deepika, are you there? No. Okay, somebody can unmute. One of the participants can unmute and say. Because if I say anybody, then a lot of people will unmute. That is a problem.
All sides are equal and each interior angle is 90 degree.
Is Anil Kumar Sharma saying all sides are?
All sides are equal and each interior angle is 90 degree.
Okay, that is your definition of a square. Of what?
Yes.
Of what?
Sir, a parallelogram whose all sides are
Anil Kumarji, you are saying all sides are equal and internal angles are 90. Of what? Of a human being?
Quadrilateral.
So what is a quadrilateral? My question.
Quadrilateral is a plane figure bounded by four sides.
Quadrilateral is a plane figure bounded by four sides. I can understand it is a plane figure. What do you mean by bounded?
Bounded means closed.
What is closed? You see, yeah, you see, that is what I'm saying. See,
yes.
We don't make our students understand what is a definition. That's why the problem comes. Yes, somebody else wants to say?
Yes, sir. Yes, sir. Savita.
Yes. Say.
For a quadrilateral is a polygon who has four lines.
Which has four lines. That's all.
Yes, sir. Yes, sir.
A
quadrilateral.
Is a quadrilateral with four sides. Okay. So the best thing is to understand it is, as Anil said, probably we should make students realize it is a closed polygon. Can polygon be open?
No.
No. So polygon means it is a closed figure.
Yes.
You start
a simple closed figure. Simple closed figure, sir.
Single, yeah. So you have to make students understand what is simple closed figure. Okay. So I'm giving you a tip as a teacher how to make students understand definitions. Many things are assumed, they are in their head, but they are not able to say it properly. Okay. So
we will start from curve.
Okay. So I'm saying do whatever you want. I'm not giving you a lecture on how to teach now. I'm giving you a lecture on how to create now geometric objects. So let us take this definition. Is a polygon with 4 sides and all interior angles 90°, as Nil Kumar Sharma has said. He didn't say the word polygon. If I added the word polygon, I would have accepted it immediately. Okay, so let us create a square using a polygonal tool. So in GeoGebra, you see this triangle. Once you go to the triangle, is GeoGebra panel visible to everybody?
Yes, sir.
Yes, sir.
Good. So when I go to this polygon, my mouse goes to the polygon tool, which is a triangle, immediately says polygon. It says select vertices and the first vertex. For polygon, there are vertices, right? And select any vertex to start with to draw the polygon. Now there are possibilities. You want to draw a arbitrary polygon, or you want to draw a regular polygon, or you want to draw a rigid polygon or a vector polygon. So let us not go to those two. Let us look at polygon and a regular polygon. So a square is a polygon with 4 sides and 4 angles. All the sides are equal and all the angles are equal. So what will you call it? That is a regular polygon which is having 4 sides. Is a 4-sided polygon, regular polygon. Is it okay? So a square can be termed as a 4-sided regular polygon. So I want to draw a polygon. So I select the regular polygon tool. Once you have selected regular, you want to start. So this is my starting vertex A. Starting vertex A. Okay. I want the side now. How long is the side you want? So this is the side I want. From A to B gives me one side of that regular polygon, and I want it 4-sided. Okay, a square has got 4 sides, so there is a possibility of changing this 4 to 5 if you want, or 4 to 6 or 3. Okay, so let us keep it as 4. So what is 4? I say okay. So it has given me a square. Okay. So this is using the tool, polygon tool with the regular polygon. Okay. So let me make it slightly up, make it slightly bigger. Now this figure, I want to make it visible in the center. So here is the last thing, move graphic view. Does everybody see this last one on the tool panel and above? This is called the tool panel. In this, the last one is move graphic view. So I click on that. Now if I come to the graphic window, I can move it up and down. I can move it left and right. I can reposition the whole graphics thing, okay, by selecting here, move graphic view. Okay. Right. I think once we are on the graphic view, you can move the graphic view, you can zoom in, okay, you can zoom in and out, okay, you can hide objects and delete objects and so on. So let us keep it up to here. Okay, zoom in, zoom out. What does zoom in will do? If I click, it will become bigger. Okay, if I zoom out, you're going away, things become smaller. Zoom in, zoom out. That is possible. So I have created a square. Let us come back to the neutral gear. Move. Okay, the neutral gear, move. Let us look at the algebra window. A, the point I created, 3, 2. The point 7, 2, that was the side of the square. It is 4-sided. Okay. And F, it shows the area. Okay. F is the length of this AB. And the polygon is a square. I have AB with side as AB. You can see it has side AB polygon and with 4-sided. And it gives the area as 16. So the area of the square is 16. Okay. So it gives all the information in the algebra window. The algebra window has everything. Okay. Now let us go to that properties thing. This is the polygon. So let me right click on this. This is a polygon. I can show object, show label, trace on, rename, delete. We have seen all this. Let me just say object properties. Okay. And to make things visible, let me make it slightly bigger. Object properties, I can change the color if I want. I can make it blue, I can make it green, whichever one I want. Okay. Opacity, how much it is now filled with green. If I make it now, inside filling is gone. I want to show the boundary only. If I want to show it darker, I can change how much opaque it should be. Okay. Right. So this is opacity. Object properties. Okay. So let me close this. I have created a square. Neutral here. Now let us click on this and I can move this square anywhere I like. Not only the segments, I can move the square, the object I have created, I can move it anywhere I like. Okay, by move tool. So this is a dynamic part of it. Recall, we started with points A and B, A and B. So let me options, let me font size slightly bigger so that it's visible to everybody. 20. And I can move these labels slightly. So go to the move tool. I can move D on this side. I can move C on this side. Okay, if I want, I can move this point A label on the left side. Now, you see the color of the points A and B. Those are the points A and B I started with. What is the color of these 2 points? Color of these points is blue. While the color of the corners of the square, other 2 corners are black. Okay. Why the difference of colors is coming? Why Geogebra is giving a different color? The reason is the following. A and B are the points I started with. I drew out on the graphic window and they were independent. They had no connection with each other. First I drew A, okay, then I made the point B. They were independent of each other. Okay, so independent objects are given this blue color. And what does independent mean? I can change it. I can change this B now. See, I can change this B. When I change this B, I move this point B, which is independent. What is happening? The original length of the square is changing because the length depended upon the segment AB. A was also independent, so I can move A also if I want. Okay. So I have the liberty of moving the independent points. But the points C and D are dependent on A and B because they were created after AB was chosen and a square was created. So I cannot move. I can move C and D. Okay. But I cannot move the point C. I can move the label, but I cannot move the point C or D. They are fixed. They are fixed according to the independent objects. So a very important thing, what are independent objects? What are dependent objects? Independent can be moved. Has everybody gotten independent, dependent things? Yes? Good. Anybody has a doubt, please ask. Then I can stop and explain again. Okay. So this is a square. You will ask me, how do you know this is a square? So let us measure the angles. Let us measure the 4 angles. So here is the angle tool. So I am introducing a new tool called the angle tool. Okay. Once you click here, you can create an angle of a particular degree. Okay. So you can measure an angle of a given size, you can do it, and so many other things are possible. So let us measure the angle. I want to measure the angle. Okay. Angles are measured in anti-clockwise direction. Very important. Angles are, I want the angle A. A is the middle point. That is the vertex of the angle. So that should be coming in the between. So starting point should be, if I go from DAB, then we are moving on this direction. DAB. BAD, you are going in this direction. So let us see what happens. B, A, and D. So it has given, okay, the starting point is B, so it has given the point BAD. But even if you don't remember clockwise, anti-clockwise, doesn't matter. B is the starting point, A is the middle point, D is the end point. It will give the angle between B, A and D. So it gives a measure also. Let me move the label. It gives the angle as 90 degrees. Now I want to measure the angle D. So how do I measure? It is between A and C. Okay. So A, D, and C. Oh, I didn't choose. I have to choose that tool. So I choose the tool angle B, A, D, and then D, A, B, and C, B. I measure all the four angles, and the measurement is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So apparently it is a square, okay, with side as AB. I want to make sure that if I move this, I'll still have a square. So let us do the move, what you call the drag test. Let me drag the point A. Can you see what is happening? What is happening to the angles? Angles remain the same. Angles are remaining the same. Now I want to measure the sides. Okay. So I want to measure how much is AB. AB was 5.8. Okay. That is already there. Okay. I want to measure what is A to D. So, but A to D is a segment. Okay. Segment I. But it is not indicated here what is the segment I. So let us create that segment. Segment A and D. So what is segment A and D? It is called it as J. What is the size of A and J? Size of the segment J is 5.8, 5.8. This is 5.8, this is 5.8. That should be good enough from the geometry point of view, saying that this is a four-sided figure with two sides, adjacent sides equal, angle 90 degree. One can prove that this is good enough to say it is a square. And still if I move, okay, it will still remain a square. Okay. Anybody wants to ask something till now? Probably we are doing very easy things. Okay. But I'm trying to introduce all the tools. Let us create a square. Okay. With here I can change. Okay. I can change the side by moving the point. Okay. The length of the side, I can change it. If I move A, the length changes. Okay. Right. Let us use another tool to create something. Okay. So I want the length to change without changing the point. I want to create a square without using the regular polygon tool. Okay. So how can I do it in geometry? How do you construct a square? Somebody has to tell me the process of constructing a square on paper and pencil without protector. Yes, somebody who will tell me. Who? Okay. If I give a name, M. Venkat, are you there? M. Venkat? No? Sanchita, are you there? I'm giving an opportunity you to talk. I'm not testing you. Sanchita, are you there? Pooja Nayak. Hello, unmute your mic and say yes.
Yes, sir.
Who is it?
Pooja Naik.
Pooja Naik. So Pooja, I am going to ask you a question. Okay. Tell me, Pooja, how do you construct a square on a paper and pencil? You are given the geometry box, but what you call compass? You are given a compass and you are given something to draw a line. So how would you construct a square? Yes.
Sir, by using ruler line segment.
So you will construct a line. Okay. Then
4 lines I will draw. I will draw a close figure.
you will draw a closed figure with 4 lines.
Yeah.
And you want to draw any property of those 4 lines?
All the 4 lines must be of equal size.
That's all? Anything more? Anything more? That is, I can also have a rhombus, na? All 4 sides equal. What will make it a square?
Sir, I am Venkatreddy speaking.
Yes, please tell me.
Sir, I want to construct a square ABCD.
Yes.
For that I am taking the side 5 centimeters.
Side has 5 centimeter. Okay.
Yes. First I construct a line segment AB is equal to 5 centimeters.
Okay.
At A I construct a perpendicular line.
Okay.
At the taking point as A and radius 5 centimeters. I will draw an arc.
Right.
Which is intersecting at a point D.
Okay.
Yes. Again taking at the point B. Again I construct one more perpendicular
line.
Yes.
Okay.
So I can put point C
and cut equal.
I can join the point C and D.
Okay. So let us do it your way on GeoGebra. Okay.
Yes.
So what I have tried to tell you is you should have in your mind first how do you construct it, and then only you can construct an applet. You should have a script ready for you. Okay. So let us. This is what I call it a script.
One more way also we can construct it.
Yeah, we can many ways. So let us do it one at a time. Let us do it one at a time. Okay?
Yes, by constructing one perpendicular or one point and constructing it at a point A 90 degrees also.
I'm not asking how many ways. Those are exercises you can try to construct in different ways a square.
Yes.
One is using this tool which is called polygon, regular polygon. Let us have another tool and another way by using this tool called perpendicular and parallel lines.
Yes, yes. Yes, parallel lines.
Okay. So let us do this. Let us take a segment first of all. So take a segment. Okay. You want a segment of a given size, segment of a given length. Okay. So segment at this point of a given length, you want length as 5. Venkat, you wanted length as 5? Okay.
Yes, sir, I have taken 5 centimeters.
Okay, let us take 5. So this is given me 5. Okay, K is equal to 5. Length is 5. Now at the point E, you want to draw a perpendicular line.
Yes.
Right? So let us go to the tool. So I am introducing now the line tools. Here is a perpendicular line.
Yes, yes.
A perpendicular line, I need it should pass through some point. It is a figure says it should pass through some point and it should be perpendicular to some other line. So I want this perpendicular line. I have chosen the perpendicular line tool. And once you choose a tool, the square becomes darker. You see the square has become dark. All other are not dark. So now at the point E, I want a line which is perpendicular to which line I want? EF. So here EF. So it has given me a line perpendicular. This line is perpendicular to the okay. We'll check it later on whether it is perpendicular or not. Now at the point E, Venkat wanted to cut here something which is 5.
Yes,
same
sir.
as K.
Same side.
Yeah. So let us, how do I cut it? By taking a, we can take it a circle. at this point, okay, and radius as 5. So radius as 5. Okay. So this is the radius as 5. So let me move it slightly up. Okay. But now I want the point of intersection of these two. I want to locate that. So for that, there is a tool in the point thing called intersect. So there is a tool in the point thing called intersect. So I select that intersect. Intersection of what and what? Two things, right? So intersection of this line and this. So this gives me the point H as my point of intersection. Okay. Now at H, I want a line which is either parallel to this or perpendicular to this. Choice is yours. Okay. So let us, we already use the perpendicular line. Let us use the parallel line. So parallel line at H, and at H I want a line parallel passing through H to K, parallel to the line segment K. So this is a parallel line. Once again, I have to cut this by
5 centimeters.
Yeah. So again, go to the circle. Okay. At H, radius I want 5. Okay. And again, I should take the intersection. So go to the intersect point, intersect this and this. Right?
So joining the 2 points.
So yeah, I have gotten the corners of my square. That is E, H, J, and F. I want to join them. To join, I have to go to the polygon tool. Now I don't want regular. I use a polygon joining these points. So I'll choose the polygon tool. Right? For the polygon tool, I start at E. Now don't leave it anywhere. Go to the H. Don't leave it. Go to the point J. It's a closed polygon. So go to the F. I want to close it now. Go back to E. So you have gotten your square by using the lines and the circle tool. Now, I don't want all this. I want to rub off the extra thing which I don't need. Okay. So I go to the neutral first. This circle I don't want. So I hide the object. Don't show the object. It is not there, but it is there in the algebra window. Okay. So don't bother. I don't want this line. So show object. I am hiding what is not required. I am rubbing them off. I am not showing them. I am not showing them. Don't show. So I have gotten my square. Let us measure the angles. Okay. So let us measure the angles again. 1, 2, and 3. 1, 2, and 3. Okay. 1, 2, and 3. Oh, sorry. I went outside. Now here is important. I made a mistake. That is very good because I have went outside. I should have clicked here. So I can undo. So here is do, redo, and undo. The first one is undo. Something you created by mistake, you can undo it. And this is redo it. So undo. This K I created, I will undo it. Okay. So this angle I want by angle tool selected. So J, F, and E. And then I want this also. So this. So all the angles are 90 degrees. All the sides are equal or not. This is E. So what is E here? Let us check what is segment E. E is 5. E is 5. J1. J1 is 5. All are 5, 5, 5. So this is sides equal, angles equal, 90 degrees. So that is a square. And here is a drag test. I can drag it. I can drag this point E anywhere. Okay. Now, why doesn't it change the shape now? Because the point E and F, they were of a given segment 5. So it doesn't change the shape. Okay. E can be moved, F can be moved, but E and F will remain the side as of a square of side 5. Anybody has a question to ask at this stage, please ask. If you have a question to ask, please ask. Nobody has a question? So you should try to draw try to draw a rectangle using this tool. Now let me continue with the square, but try to change it a bit. So I don't want to, I will go to the new, I will not save it and something. I want to introduce you. I want to draw okay, yeah. So let us draw a line, okay. Let us draw, I'm just innovating. Let us draw a point. This is a point. Let us draw a line through this. A line through this. So how many points a line requires? Rajni Kala, are you there?
Yeah.
Rajni Kala, how many? What is a line?
2 points are required.
2 points. So A, another point. Now, where should I put the other point? My choice. So let me put the other point as B. Okay. So that is the other point. So there is a line passing through the points A and B. Okay. Now, I want to cut a line segment from here, okay, of a given length. But the length is variable. It could be 1, it could be 2, it could be 3, it could be 5. For that, so a variable length, okay, a variable thing is the best done with the help of a slider. So let us have the new thing coming up is slider. So I'm putting a slider. I'm selecting the slider tool. I'm putting the slider here. What name I want to give the slider? Okay, let us keep it as A. It is a number. This A slider is a variable which will indicate some number. It can be an angle or it can be an integer. Okay, whatever you like. So let us keep it as a number A. What length you want? It could be -5 or 5, but normally length is not non-zero. So let us keep it as 0. Okay, 0. Okay, let us. So it has given a slider with length as A. At present is equal to 1. Okay. Why it is called slider? I can slide it. When I slide, the value of A will change. Okay. Let me increase the font again. Increase font size to 20. Can you see the slider value changing?
Yes, sir. Yes, sir.
Okay, good. Now, what I want a segment starting at A, okay, of length 2.4. I want to cut this point, cut this line, okay. So what I do to cut, I should go on a circle of a given radius. So circle with center at A, and what is the radius? I want radius to be equal to A. So I put that value A. You see, A need not be a number. It could be a variable, A. So, okay. So what has it given me? It has given me center as A and radius equal to 1. Can you see the radius is equal to 2.4? Sorry. So the radius is x minus a square plus y minus b square added up gives you r square. So r is equal to a. If you want to change, want to keep it as number as radius, let me rename it and call it as r so that it is a radius. Okay. So there is a radius. If you want to give a more descriptive way of saying, so let me take a point on the circle, take a point on the object. I want to take a point on the circle. So let us take a point C on the circle. Okay. And this should be equal to the radius. So let us take the segment, tool and join it A with C and G. So what is the length of G? 2.4, that is same as the radius R. Both are same. Right? Now, why did I do all this? I could have drawn a circle around this with this as radius. Right? But now the advantage is when I move this, you see, the radius is changing according to my liking. The radius is changing according to my liking. Right? Now I can, this radius, I am moving it manually. Okay? I am moving it manually. Oh, why? I forgot. I should cut this point. Okay? I should have cut that point. So let us take the intersection. I didn't do that. Let us intersect the circle with this. The point of intersection is E. I don't need that line now. So let me hide that line. Don't show the object. I don't want the point B. So let me hide that. This point E is also on the line. What do you think the DE would be? What is the length DE?
It is the diameter.
That should be the diameter, right? Because D and E. Okay, so let us check whether it is or not. So let us take the segment, draw a segment between D and E, that is N. Okay, is that double of R?
Yes.
2.6, that is R. So that is actually the diameter. That many ways of asking students, right, bringing interactivity in the class by such kind of things. Like you are reacting, your students will react. Okay. Now, why did I do the slider thing? Now I change the slider. You see what is happening. When I change the slider, your circle is changing. Right? Instead of manually animating, I can, this slider, again properties. I can show object and right, various things, right? I can change the color. There is something very special called animation on. Let me select animation on and see what happens. When I select animation on, what is happening? The slider values are changing automatically.
Yes.
I'm not doing anything. It is bringing dynamism of the second level. It is making radius 0 point, it is making. I can stop it. Here is the button for animation. I can stop, pause. Okay. I can pause anytime I like. Okay. I can pause it. So this is how you bring animation. I pause it. If you want, you don't want animation, you can remove that animation. Animation, okay, on, okay. You can remove animation if you want, but let me not do it for the time being. Okay, I want to do you. Okay, here is something hiding thing. See this neutral gear. I want to hide the axis because axis is not important for me. So I select the graphics view. Okay, and I right click on this. I select graphics. I right click on the graphic window. It says me axis, grid, and so on. So let us click on the grid. Let us click on the grid and axis. They are gone. Axis, if I want to bring back the axis, I will click again, axis will come. If I click grid, again it will come. So sometimes you want the grid, sometimes you don't want, sometimes you don't want the axis, sometimes you don't want the grid or one of them. So whatever you want, you can do that. Right? Now, here is another important thing. I trace, I already showed you, but let us do trace on this point C. Where is the point C? C is a point on the circle. Okay, so let us go to the neutral gear. Let us select the properties and let me put trace on. I'm selecting trace. So wherever the point C will go, trace will be shown. Where is the point C going? And let me do the animation on and see what is happening. Okay. Now, this is fun anyway. Okay. But I want to make a interactive thing for the classroom. Let me pause it. I can ask a student, okay, okay, here is something. When you view, you can say refresh. So the trace will be gone. Okay. Now I will ask my student that I have a circle whose radius is changing. C is a point on the circle. When I change the radius, center as fixed, the point C will change. What will be the locus of that point? So here is a question. What is the locus of the point C, okay, which is on the circle of a moving radius but a fixed center? So exploration can be that I can put the animation on, and so this should be my, so that gives me the locus as the radius goes from 0 to 2 point whatever it is, 2 point or radius goes to 4 point something. So radius is a straight line passing through C and the center. Okay, let me pause it and let us change the point. So let us view, let us refresh, and let us change the point C. C was any point. Let me change the point C. For trace was on, I forgot. Okay, now let us find out what is the trace. Okay, I changed the position and let us find out the trace of this. So what does it? It says if I take a point C on the circle of varying radius with center fixed, then its locus is going to be a straight line passing through the point and the center, irrespective where the point C is. So let me pause it here. So let me ask what kind of questions you would like to ask. I don't know. I have gone the way I wanted to do. Any questions you would like to ask? Any questions till now you would like to ask? Who is monitoring the time? Anybody monitoring?
Yes, sir.
Rohit, how much
Yes,
more?
sir.
How much more time I should take?
More 15 minutes. You
More
can
15 minutes. Ram
Yes, sir.
Katha going on. It can continue, na?
No issues, sir.
When you feel tired, tell me. I think I'll take about 15 minutes more and then stop. Okay.
Okay,
So
sir.
here is something. It is called a stick figure. In cartoons, it is called a stick figure. Right? That means it looks like there is a, I don't know, probably a character with a head. This is the body of the character. This is the upper part. This is the lower part. This is one arm. This is the other arm, one leg, and second leg. Okay. Triangles can be like circles. Triangles can be made on. Let me just show you. Here is that tool, polygon tool. Triangle is a polygon with three sides. So 1, 2, 3 closed. A polygon with closed figure with three sides. So we can close it. Okay. Right. So I created this, but probably you should try to create also yourself later on this figure, stick figure. So how did I create this figure? So here is the Geogebra applet. So what I have done, this is a Geogebra applet, okay, with some slider, which is a number A, and with some angle slider as 6. Okay. Let us see what does the sliders animate. So let me animate. So what are the things happening? This thing, okay, the number A, let me show you the object label 1.3. So this radius is changing, okay, and this R is moving by an angle alpha. This also is moving by an angle alpha. Okay. So this is bringing something called rotation. So let me pause it. Let us rotate this thing around this point. So let me rotate. So there is a tool. Okay. So here is rotate around a point. Rotate point, rotate around a point. So you can rotate an object around a point. So what I want to do, I want to rotate this leg. Okay. I want to rotate this leg by an angle alpha. Okay. So let us select the tool. Where is the tool? Rotate. Rotate. I want to rotate this object. About what? I want to rotate about this or this point. To make it a dancing figure, I should rotate it around this point, rotate about this point. So what is the angle I want to rotate? Not 45 degrees. I have already named that alpha. How do I type alpha here? In your keyboard, alpha is not available. So here is the symbols given on the side. Okay. When I click here, it gives all the Greek letters and many other things. So let me choose, because I slider is alpha. So let me choose alpha and click OK. So alpha was 4 degrees. It has already rotated. Now I put the animation on. You see what is happening? This leg is also rotating. Maybe I don't want to show the original one. So let me hide it and hide this object. Now only the rotating thing will be shown. I can make this rotate, I can make this rotate, and so on. So these are the tools, geometric tools. I can reflect around a line, reflect about a point, reflect about a circle, rotate, translate, dilate. Various things are possible. Explore what does what. Okay. So let me pause and ask you if you have any questions to ask. Otherwise, I will just do one or two things more and stop. Anybody wants to ask something? So we have covered the move. We have covered the point tool, point on an object, midpoint. I have not done midpoint. Probably we should do that. Lines, triangles, polygons, circles, ellipses, conics, angles, and slider rotations. Okay. Let us go over something more so that you are exposed. So this is all we have done till now. Polygon tool we have done. Creating a square we have done. Let us do this rectangle. Okay. Probably I think we can use the earlier one. This is a triangle we have done. Let us find out the medians of this triangle. I will not ask you again what are the definition of a median. Median is a line joining the vertex with the midpoint of the opposite side. So I want the midpoint of GH. So there is a midpoint tool available here, the midpoint or the center. So in the points, there is a midpoint. Click on midpoint and click on this F. It gives you the midpoint. Click on this side, it gives you the midpoint. Click on this side, it gives you the midpoint. So let us join the line segments and find out the medians. This is the midpoint. This is the other median. And this is the third median. All the medians meet at a point. There is a theorem. All the medians are concurrent. That means they should meet at a point. And let us find out the intersection of this. Intersect. Any two is good enough. That gives the median. And now, why I said it is dynamic, you can tell the students, look, whatever be the triangle, wherever be the triangle, okay, the medians always stay at the same point. They are concurrent. So this can be taken as a visualization but it can also be taken as a exploration. One can do many explorations with the medians. I'm not, I think, going to do that. Construct a triangle, construct the medians, and show that. For example, you can take a triangle, find out the midpoint, take any point, and draw this segment and move this, okay, and try to see that when P coincides with D, D is a midpoint. Okay, so definition of midpoint: the line with a point on the opposite sides is a median only when P is the midpoint. Many explorations are possible. So we do it in the classroom when we teach geometry. So let us not go through explorations. Skip that because we don't have. And this is the one which is says ratio of. This is called the centroid. The ratio of AG to GE should be equal to 2. And you can have a dynamic way of showing this text. So let me probably, I think, show you because there is something new. You can have a checkbox using here. If I click this, there is a checkbox. You can create a checkbox, okay, with a name on it. So it says create a checkbox, and what objects it should show, okay. It will show something which I have already created. Here is a text, okay. So this text will be shown once I select this. So this is the text I created, and this checkbox has the option show something when ticked yes. Okay. If I take it off, what is shown is gone. Okay. When I click, is on. And what is interesting and important, this ratio is a dynamic thing. The lengths are changing. The lengths are changing, but the ratio remains 2. So that should be a theorem. And that's what we prove in the classroom. Okay. Almost everything in geometry. Here is something I created. Again, this windmill thing by rotation. Okay. Now I'll quickly show you. Animation on. So here is the animation on. Somebody's mic is on, please switch off. Okay. I think I have done enough. Probably
Anil Kumar sir.
Yes.
अपना माइक बंद करिए. Okay, let me give you 5 minutes to think about a problem, how GeoGebra can be used to solve some problems. So there is a problem from a book by George Gamos on puzzles in mathematics. So a young man found a treasure map. So here is a treasure map he discovered. He says the map says that go to a particular island. On the island there is a house, a coconut tree, and there is a mango tree. There is a house, there is a coconut tree, and there is a mango tree. He says, how do you find the treasure? From the house, you go to the coconut tree, keep track of how much you have moved, and from the coconut tree, go to a point A, which is on the 90 degrees on the left side with as much distance. So distance of C to A is same as distance H to C, but on a line which is at 90 degrees. So you get the point A. Come back to the house, go to the point M, that is a mango tree, measure the distance you have, turn to the right now, that was on the left, turn to the right, okay, by 90 degrees, and walk as much as you have walked from H to M. You get a point B. Locate the midpoint of AB. The treasure is hidden there. Okay, so that is the map. So the young man took the map, took a boat, went to the island, and wanted to dig out. Okay, so here is. But once he reached the island, he found there is no house. Only two trees are there, mango and coconut. But the hint to locate the treasure was start from the house and go to coconut and house to mango. But there is no tree. So the poor chap was very much disappointed. So what did he do? He tried to dig around, but got frustrated he couldn't locate. Can you suggest what he should have done? I give you 2 minutes to think about a solution, and then we'll have a solution in GeoGebra. So everybody think for 2 minutes, try to find a solution for this. And if you want the problem again, here is the problem. Okay, if that helps you.
So, till then, I'll inform the participants regarding the attendance form to be filled. So, all the participants are requested to fill the attendance cum feedback form which has been put in the chat box, which will be open for around 20 minutes. Thank you.
Anybody would like to respond? I think people must be tired of thinking, probably.
Sir, let us fill the attendance form, sir, please.
Okay, you want me to stop?
Give us 2 minutes, sir.
Oh, okay. Fill the attendance form. I give you 2 minutes.
You will have 20 minutes after the session also. After the session, 20 minutes will be provided to fill the form. No issues.
So graciously, Rohit has said you can take 20 minutes after the session. So
Sir,
please.
Sir, from where you will get the attendance sheet, sir?
Rohit, from where
Hello,
will you
sir.
get attendance? Put it in the chat box.
It is provided in the chat box. I have sent it in the chat box.
Okay, sir. Okay.
I'll send it again if.
Nobody ready with an answer? Guess. In mathematics, you have to make a guess. Then only you can help to prove it. I think probably, Rohit, we should stop. Hello, Rohit.
Okay, so thank you for your insightful session. With this, I now hand it over to Ms. Sanchita Rane for vote of thanks. Ms. Sanchita, are you there? I think.
Yeah. Thanks. Accepted.
Okay, sir. Okay, sir. Wait.
Okay, so if anybody,
okay, sir.
Anybody else?
So thank you for your knowledge, for sharing your knowledge today. I'm sure that we'll be applying this knowledge to make mathematics more fun. Once again, thank you for making our learning experience enjoyable and informative. Thank you.
So the second session will discuss more advanced topics by Surendranath Reddy. That will be tomorrow. And if you want to reach me, you can ask. Email is ikrana@gmail.com. Okay. And questions, doubts about the session you want to ask or anything else I can help, I'll be happy to do that. So thank you very much.
Thank you, sir.
Yeah.
Thank you,
you,
sir.
Sandra. Bye. Take care.
Thank you, sir.
Enjoy Geogebra.
Thank you, sir.
Yes, sir.
Thank you, sir.
Yeah, Mr. Rohit. Mr. Rohit. Yeah. Mr. Rohit.
Yes, miss.
Yeah, I opened the link and I filled the form.
Okay.
And then while
Okay.
giving the feedback for organizers,
Huh.
I'm not able to click on the circle. What could
Okay,
be
I'll get
wrong?
back to you.
Yeah, please.
Okay, I'll get back to you.
Yeah, thank you.
I checked, miss. The things are working fine.
Yeah, right. I refreshed it. Now it is working. Thank you
Okay.
so much. Thank you so much.
Okay, for tomorrow the session will be at 2:15 in the afternoon.
Thank you. Thank you so much.